So welcome. This is sort of a first for the Apache Unomi project. The idea is that since some of these contributions can be quite big, the idea was to present it instead of just having a pull request to review. And so I have some. Yes, I'm recording right now. No, it's I'm not recording. That's a good question because I don't know if I can record. No, but I'm recording my side of the session, so maybe I'll have to repeat some questions if you have questions. But so yeah, sorry about that. Yeah, so there will be a recording of the main session. Yeah, I have some slides to sort of walk you through the different things, and at the same time, and during the slides, I'll try to do some demonstrations of some of the stuff I can demonstrate. And yeah, don't hesitate to interrupt me at any time. All right, so yeah, the topic is the OpenSearch integration. So, a quick overview of the work that's been done. I'm introducing support for OpenSearch version 2.18.0, which is currently the latest version of OpenSearch. The thing is that one of the big goals was to do minimal changes to the Elasticsearch implementation. Um, but then I had a few things that I had to do during the process of development because I ran into a lot of issues while I was working and I had to improve some tooling. So I will be showing you also an enhanced build system, an improved testing infrastructure, and some other developer experience improvements. I've put the link to the pull request here and as well as the Unomi ticket that tracks this work. So the first question is why OpenSearch? So this has come back to the community from different parts of the community. One of them was the Apache board, which did not really like the fact that an Apache project was dependent on a non-Apache licensed product. But there was also interest from other groups, even including Amazon, that were looking at OpenSearch support for Unomi. So OpenSearch is fully Apache 2 license. It's community-driven development. There's no licensing restrictions, so all the features are available for free. Of course, since Amazon was a big sponsor of the work, it has good integration with AWS. And now they have a new architecture that is quite future-proof with a lot of modules and plugins. Of course, the big benefit for people coming from Elasticsearch is that it's wire compatible, meaning that everything that goes over REST requests is compatible with Elasticsearch. There's also some enhanced security features out of the box, which are only available in the commercial versions of Elasticsearch. There's native performance and optimizations, and we'll see also that there's some possibilities to migrate between the two. So I talked very quickly about the version that are supported. So right now we differentiate between the library and the runtime. So the runtime versions of the search engines that are supported are Elasticsearch 7.17.5. This has not been changed in the pull request. I haven't changed that. And OpenSearch 2.18.0, which is currently the latest. I think they're going to release a new version in the coming months. On the libraries part, that's very different. We're using the Elasticsearch 7.4.2 library because it's one that's still Apache 2 licensed. We do not have the possibility to use non-Apache 2 licensed or non-Apache compatible license inside the product, inside of Unomi. And for OpenSearch, of course, it's the latest, which is Apache 2 licensed. Now, I want to talk very quickly about improvements to the build system of Unomi. This was sort of something that was not out of the box, that was improved. So one of the problems was the support for multiple search engines, having a better developer experience, improving the integration testing, and also having clearer progress indicators. So here there's quite a few things that have happened. So there's a new build script. You can see some screenshots here. It replaces the old build scripts that were in the project. And I'll show you very quickly afterwards how it works. And there's also the Maven cache build extension that's also built in the project. So this is an extension from Maven itself that will try to avoid rebuilding stuff if it doesn't need to be rebuilt. So even if you do a Maven clean, it will recalculate all the changes. It's very similar to those of you who are familiar with Gradle does. It's integrated now. There's also this also helped me save a lot of time in terms of development because I didn't have to start from scratch all the time. There's progress tracking. You can see here now you have like these progress bars. There's better error handling in the script. So if there's an error throughout the script will stop properly and not continue. And you have like options for search engine and stuff like that. So let me just show you quickly. So here I'm at the root, and so if I do just build.sh here, if I do this by default, it will build and then launch Karaf. But here if I type -help, I will get all the different options. So I can say if I want to skip the tests or if I want to run the integration tests. If I want to deploy after the build, we had a separate script for that. If I want to enable the Maven debug mode, offline, if I want to launch Karaf in debug mode, stuff like that. And then there's also stuff for the new Maven cache that was introduced, so you can control whether you want to disable the build cache, or if you would just want to purge it. So you want to say, okay, I want to be sure I'm starting from 0, so you can just say, okay, you just give this option, purge Maven cache, and we'll clean the cache before you launch it. And here you have the option to use OpenSearch. So by default, if you run the integration test, it will run with Elasticsearch. But if you use this flag, it will run the integration test with OpenSearch. Okay, let's get back to the slides. Oh yeah, no, I can show you one more thing. So if I launch now, the thing, you'll see that it's a script that does a few checks before it starts. It's might be slowed down or so by that. Yeah, so you see it gives you an estimate of time for a building. The progress bars are not ideal, but here you can see, for example, yeah, it's that was just a clean part, and now it's scanning the project for building and stuff. I'm not gonna go through all of, well, actually, I might let it run while I talk through the rest. So yeah, you'll see here it says skipping plugging execution cached. So this is the build cache that's actually doing its work. So here we see we're already at the build the generation of the package, because yeah, here now it's done. So here I completed the build with a clean install in I don't even know if I can show the time, but it's much shorter. Yeah, with 28 seconds I did a complete build because, of course, of the cache. So now I can just shut down this and get back to the slides. All right. So on the testing infrastructure, so here the idea was to be able to make sure that we continue executing the tests that we have, but we also execute the new OpenSearch ones. So there were also some improvements here because I spent a lot of time working on the integration tests, and it was growing really frustrating. So there's some few improvements to them. So now you have sort of listeners for the integration tests. They show you like the number of tests it's found. Then you have like progress bars here to tell you while the tests are running, how many tests have been executed. And you can also, here it's cut, but you can also see the amount of successful and failed tests even during the test, which was previously not available. And when the tests are finished, what's also interesting is that it now outputs the longest duration, the 10 SARS tests, sorry. And so that's also very helpful to look at, okay, if we want to improve the tests time, where can we focus on? So I also wanted to show you here, if I go here to the checks, so you can see here that I have 2 jobs. And so I have the OpenSearch, this one is Elasticsearch, and the OpenSearch here that are both running all the 183 tests. Another tool that was very useful was, I don't know how many of you are familiar with using the integration tests, but often you have to look at the logs. And unfortunately, in PAX exam, which is the system we use to run the test, it generates a UID for the test run every time. And so it was becoming really tedious to work with those all the time, to do pushd target and having to, well, you can autocomplete, but basically I also introduced a small script here that makes this a lot easier. So if I go into the integration tests here, and I do just kt.sh, and then I get all the instructions here that I can use, and I can just say, okay, for example, I want to do ktl, and then I immediately view the latest logs of the integration tests. So that makes it very easy. I can also do g error, for example, and that will do a grep of all the errors that are in the file. So it's small utilities, but they saved a lot of time in development. So also, there's some new caref shell commands that were introduced. So again, because I was working on core work, I was having all kinds of issues with some stuff deploying halfway and stuff like that. So I started implementing the remove commands, because we had options to deploy or to add or to list all of these objects, but we didn't have anything to remove them. So these have been very useful to have. Okay, so what I'm going to do now is I'm going to quickly show you a demonstration of running the different versions of Unomi. So I'm going to do docker compose -f, docker compose build yes, so Elasticsearch and up. So here what I'm doing is I have a docker compose file that says that I want to start Elasticsearch and Unomi locally, so I can check that everything works correctly. So this is just going to take a few seconds, and now Unomi is starting up. And so this is running Elasticsearch right now. And so the same Docker image is used for Elasticsearch and OpenSearch. There is not 2 different ones. It's the same one. Okay, did we get all the way through? Yep. All right, so now what I can do is I can go into the health checks here, and I'll just reload. And you can see here, so the health check, for those of you who are not familiar with it, it's a servlet that's aimed at integrating with monitoring systems. So it just returns a JSON that tells you what's going on in the backend. And so you can see here that Elasticsearch is live, and you can see that caref is live. The persistence has an error. I just saw there's a small bug, but I'll have to look at that. And the cluster is live, and everything else is running. Now, I'm I'm gonna now what I'm gonna do is this is just the error. It's a minor thing, but I have to look at it. It doesn't impact the rest. All the tests run with that, so it should not be something important. So now I'm shutting this down, and one of the things that you should know is that Elasticsearch, at least for these older versions, is not very secure by default. And an OpenSearch on this latest version is much more demanding in terms of security. So one of the things we need to do is, before we start the Docker Compose, we have to set up a password for OpenSearch. And so this is what I'm doing here. And then I can actually start the Docker Compose. So it's build OpenSearch up. And so now you'll see that we're running actually 2 nodes. The default installation of OpenSearch comes with 3 images, basically node 1, node 2, and the dashboards, which is actually Kibana. And of course we have Unomi as well, that's starting up. So all this is now coming. Okay, did it finish? Yep. Yeah, I think so. All right, so now if we reload the health check, you can see here that we have OpenSearch that's live, and so everything here is up and running. Okay, so what I can do now is I'm going to quickly go into connect to the local SSH. So for those of you who are not familiar, you can log in with SSH into a Unomi server, and there you can run commands. So here I can, for example, say I want to see the list of sessions. Well, there's nothing because it's empty. I can look at the list of actions, the list of conditions, the list of rules, all these different objects. I mean, here of course I made the screen, the font very big, so it doesn't look like much, but on smaller fonts it looks a lot better. And now what I can do is I can, for example, say I want to mess up my system a little bit. Well, not mess it up, but create some data. So I'm gonna perform a manual request here, and I'm gonna give a session ID of something that I don't really want to keep, so I'll just say demo OpenSearch. So here I get an answer, and if I look at what happened here is I now have a session called demo OpenSearch. I can view the contents, and if I look at the list of profiles, I also have now a profile that has been created because I did the request on the session. Now, this is where I had some issues, was that I wanted to remove the session because it was creating issues. It was corrupted and stuff like that. So now I can just do demo OpenSearch. And here it asks me for confirmation, so I'll just say yes. And now if I go back to the list, you can see that it's gone, but the profile is still there because the profile is independent from the session. All right. So we've done this, we've done this. Okay, now I want to talk quickly about how this was implemented. So we basically have an Elasticsearch implementation of what we call the persistence layer. And so what I did is that I introduced a new version called OpenSearch. And in the directory structure, it's very straightforward. The persistence SPI, service provider interface, had to be improved to be able to handle some things that are common to both engines, but most of it is pretty straightforward. From an architectural point of view, so now we have 2 implementations of the persistence service. So the OpenSearch one is the new one. And on the query builders, so these are the classes that transform the tree of conditions that we send in a request or we store in a rule into actually requests for Elasticsearch or OpenSearch. And so here we had to do two implementations. I mean, we have the Elasticsearch one, but we had to add a new one for OpenSearch. So this meant that all the classes for building query builders for Elasticsearch had sort of been duplicated for OpenSearch. So one of the question is you might have is why why did I do it this way? So by design, Unomi has different condition builders for either accessing the persistence service or real-time conditions. So we already had two different systems of building conditions. And so here it made sense to add a new one for a new implementation to avoid breaking all the other existing ones. By doing that, we completely avoid modifying the Elasticsearch implementation. So that could live with an older version of the library. Of course, as it's different libraries, you have different package names, so you couldn't use the same code to do both. They have incompatible API signatures. This is mostly because the Elasticsearch driver is much older. If we move to more recent versions of the Elasticsearch library, it would look closer to the OpenSearch one. As I said, there are version-specific features and the security model differences, not very major ones, but there are some minor ones. So yeah, I don't want to get too much into the details, but this is sort of what I said already. There's different domain-specific languages for the queries in the different engines. So this is one of the reasons I had to do it this way. I did, of course, consider other approaches like abstract approaches, which is sort of what I did when I moved some of the code to the persistence SPI. But I didn't want to do it further than that because it would have been a lot more complex. The way this is done is much easier, and adapter patterns are always complicated. They introduce all kinds of additional complexity. It would not have been efficient. So yeah, I think I went off through all of this. One of the things I should mention is that this makes really the testing very easy because you have really two separate implementations that you can just switch between. So one of the things that was required is Unomi has a start command. And so when you launch without a Docker container, you will have to start Unomi. And so what was done here is that instead of using just Unomi start, you now say Unomi start Elasticsearch or Unomi start OpenSearch. And that will tell the system which persistence system it should use. But in order to do that, I ran into some issues with the system, the way that the start was implemented. It was a hard-coded list of bundles that we were starting, and meaning that we couldn't customize it. It was really hard-coded in the code, and you could not, of course, select an engine. I tried different solutions, but what was ended up as being the best one was to separate all the stuff for startup into features, scarf features, and then use configuration to be able to list. So this is what you see on the right here. You can see which features are started for which subsystem. So for Elasticsearch, we have persistence Elasticsearch feature, Unomi services, Unomi Caraf router, and stuff like that. One of the good side effects of this is that you could imagine packaging additional features into your build of Unomi and easily add them here. So just through configuration. Now, I did have some technical issues with the startup of features. So by default, startup features are deactivated by default, and then manually in the codes started when it's needed. This is because I ran into a problem with PaxWeb reloading. It's an issue on PaxWeb. So this will be resolved once we upgrade to a more recent version of the PaxWeb's library. For the auto start, so I've already demonstrated this feature, but basically you can tell Unomi to auto start in a different, auto start immediately when you start the graph. So we used to only have like auto start true, and that's it. And now this has changed to auto start OpenSearch or auto start Elasticsearch. Or if it's still compatible with true, so you don't even have to change your Docker configurations. It will automatically start Elasticsearch if it's set to true. So that's basically how the Docker images work now. You just say which auto start you want. I've also worked on the documentation. So basically everywhere where we were talking about Elasticsearch configuration, I've added stuff related to OpenSearch. I've also started an OpenSearch migration guide. So I found a tool called OpenSearch Migration provided by the OpenSearch project that is really aimed at migrating from Elasticsearch to OpenSearch. So I started writing the guide, but I haven't tested the procedure yet. But except for that, everything, including integration tests, documentation, readmes, all the documentation in the manuals has been updated. What has not been updated is the website. But once this PR is merged, I can get onto that and update the website where needed. So the future roadmap. So what still needs to sort of be done. So the review, of course, of the PR and the merging, fixing any bugs that might have been missed. As I said, the tests are 100% running, both locally and on the GitHub runners. And of course, there could be some additional features such as improving optimizations, extending testing, testing the OpenSearch migration tool, and also looking at the tooling that I did and maybe improving it. And of course, one of the big things is any feedback from the community, which also is very interesting to take as input. So that's it for the presentation part, let's say, and the demo part. If you have any questions, I'd love to hear them now. Yes, well, I mean, there is, most of the ways that Unomi has started now is through Docker images. So what I have in the Docker Compose files is really that. I mean, basically in the Docker Compose, you have the option which you want to use. So you can just configure that Docker Compose and that's it. Yes. Yeah. Oh, yes. That's for the test because I needed a way to quickly run the tests in Elasticsearch or OpenSearch. That was very important because really my objective was to not break anything on the Elasticsearch implementation. No, no. But the one of the questions was that I had myself was about performance, and the best thing I can say is on the tests, you can see here that Elasticsearch takes 40 minutes and OpenSearch takes 43 minutes. So this might be environment also. But yeah, we'll have to see. But the main objective was, I mean, if you're focused on performance, I guess Elasticsearch will probably be better. But if you're focused on, for example, what I'm focused a lot now is on reducing the cost of deployment of Unomi, and so it's a trade-off. You probably would, if you need absolute performance, probably Elasticsearch will behave a little bit better. But if you need to lower your costs, I think OpenSearch is probably the best option. There's a lot of stuff, from my experience, there's a lot of stuff that comes out of the box in OpenSearch that are options that you have to pay for. In, for example, all the machine learning stuff. And in terms of code, I mean, for the libraries, it's completely. I mean, the functionality is the same because it ends up, building the same REST request, but it's completely different code. I had to basically rewrite the OpenSearch, the persistence implementation completely. It wasn't difficult work because it's mostly converting, the method calls and stuff. But I think that file is 2,000 or 3,000 lines long, so it took a while. And I should also mention that even some features like the rollover for indices that we use for events is also working with OpenSearch. So we had configured an automatic rollover so that when an index reaches an event index reaches a certain size, it creates a new one, and then it points to the new one, and so that's also implemented. No, that was in the Elasticsearch implementation for Unomi, and I wasn't sure if I could reproduce it with OpenSearch. Hmm. Yes, yeah. Well, yes, it is. It's basically just that when the persistence service starts on Unomi, it sets up the rule, and it's code that just sends a request and says, okay, this is the rule. And it's a little bit different on OpenSearch because they have something that they call policies, and so it's integrated with their security policies. And so I had to sort of completely change the thing because it was a different way of setting things up, but the functionality is the same. But you'll see that based on what I presented, this should really help in the review because you sort of get a map of, okay, this was changed, but I understand why this was done and stuff. Most of the OpenSearch code should be pretty straightforward to review because it's really one-to-one equivalent with the OpenSearch. There's basically the same class names for both, and no, it doesn't have support for the migration. No, no, but you could add it. It could be added. By the way, on the migration, I should point out that the migrate test code from 1.6 to 2.0 is bypassed on OpenSearch because it doesn't really make sense to run migration from 1.6 to 2.0 because there's nobody using that. And so here and there's no, I don't have a snapshot for it either. I sort of took that shortcut because I thought nobody's going to be doing that migration.